Imagine holding a book in your hands and realizing that every page began as fibers, chemicals, heat, water, ink, pressure, and thousands of precisely timed movements. What looks like a simple stack of paper actually passes through forests, pulp mills, paper machines, printing presses, cutting systems, folding lines, and binding equipment before it becomes something you can read. And here's what nobody tells you. A modern book can pass through more industrial processes than you ever imagined. Today, you're going inside that hidden world to see exactly how a book is born. Most people never think about this, but the journey starts long before a printer ever touches a page. Paper usually begins with cellulose fiber from wood, although recycled paper and non-wood fibers such as bamboo, straw, and agricultural residues can also enter the supply chain. In a typical wood-based system, logs or chips arrive at a pulp mill, where machines remove bark, reduce the wood to chips, and separate useful cellulose fibers from lignin and other components. That tiny fiber will eventually become the surface beneath the words you're reading right now. Think about this. The raw material does not simply become paper by being crushed. At the mill, rotating equipment removes bark, large drums and conveyors handle the wood, and chippers cut logs into controlled pieces. The chips then move toward pulping, where manufacturers use mechanical or chemical methods to free cellulose fibers from the wood structure. In chemical pulping, heat, pressure, and alkaline cooking liquor break down much of the lignin that holds the fibers together. The exact recipe changes with the pulp grade, mill design, and final paper specification, so there's no single temperature or pressure that every book paper mill uses. But here's the surprising part. The paper mill is not trying to make a white sheet yet. It first has to create a stable pulp with fibers that can form a strong web. The pulp gets washed and cleaned, and depending on the intended grade, manufacturers may bleach it to reach the required brightness. Modern mills recover chemicals, energy, and useful byproducts wherever possible, while wastewater treatment systems work continuously to reduce pollutants before discharge. The environmental footprint remains significant, especially because pulp and paper manufacturing demands large amounts of energy, water, and processed chemicals. Now, the liquid pulp reaches a paper machine, one of the most extraordinary machines in the entire journey. A carefully diluted fiber suspension spreads across a moving, forming section, where water drains away while millions of cellulose fibers begin locking together into a continuous web. Powerful presses squeeze out more water, and heated drying sections remove much of what remains. The line can stretch across a huge factory floor, turning a flowing suspension into an apparently ordinary sheet at remarkable speed. And once that sheet reaches a correct moisture, thickness, smoothness, and strength, the next transformation begins. The finished paper is wound into enormous rolls, sometimes weighing hundreds of kilograms or far more depending on the mill and roll dimensions. But a book cannot use a giant industrial roll as its pages. The paper must meet precise specifications for thickness, basis weight, opacity, smoothness, moisture, and surface performance. Sensors continuously monitor the moving web, while operators inspect samples and adjust the machine when measurements drift. A microscopic variation in paper can later affect how ink spreads, how pages turn, and how the finished book feels between your fingers. And now comes a completely different world. Printing. 4 large print runs. Offset lithography remains a major book production method. Digital files become printing plates, and the plate transfers an image to a rubber blanket before the blanket transfers the image onto paper. The press separates colors through carefully controlled printing units, usually using cyan, magenta, yellow, and black to reproduce a huge range of images and tones. At full production speed, the machine becomes a blur of paper, rollers, ink, air, and sound. Listen closely, and you can almost hear the factory breathing. Rollers spin. Sheets snap through guides. Pumps circulate ink. Compressed air separates sheets, and mechanical systems keep every page aligned. Operators constantly watch registration marks and color targets because a tiny shift can make text look soft or cause colored images to misalign. Some presses use sheet-fed paper, while others use large rolls that later get folded and trimmed. Either way, the objective is simple. Thousands of pages must look like they belong to the same book. But printing the words is only half the story. Once the pages leave the press, they may be folded into signatures, where large printed sheets become organized groups of consecutive pages. Folding machines use rollers, blades, and guides to create extremely accurate creases. The signatures are moved toward gathering equipment, which places them in the correct sequence. Imagine taking hundreds of loose pages and having a machine arrange every chapter automatically, thousands of times without losing the order. That is where the book begins to look like a book. Now comes the moment where a pile of paper finally becomes a physical volume. Depending on the design, machines can bind the pages with adhesive, thread, staples, or combinations of methods. Perfect binding trims the gathered pages and applies adhesive along the spine before attaching the cover, while hardcover production adds additional operations for boards, covering material, end papers, and case assembly. The adhesive must spread consistently, the pages must sit squarely, and the cover must land in exactly the right position. 1 millimeter of misalignment can become obvious when hundreds of identical books sit together on a shelf. For a hardcover book, the process becomes even more impressive. Thick boards are cut to control dimensions, covered with printed or decorative material, and joined with a prepared book block. End papers connect the inside pages to the cover, while pressing equipment helps establish clean joints and professional shape. The finished cover may receive foil, embossing, lamination, or protective coatings depending on the design. Suddenly, the raw forest fiber from the beginning has become a structured object with a spine, cover, pages, and a purpose. But here's where technology takes over. Modern production lines can use cameras, sensors, barcode systems, automated controls, and computerized inspection equipment to monitor everything from page sequence to print quality and binding position. Vision systems can detect missing pages, damaged covers, color problems, crooked cuts, or other visible defects far faster than a person can inspect every book individually. Still, machines do not replace human judgment completely. Experienced operators know when a strange sound, unusual paper behavior, or subtle change in ink tells them that something is beginning to go wrong. Think about this. A book can be mechanically perfect and still fail because the reader notices something the machine does not. A human inspector can catch a strange crease, a cover that feels wrong, a page that turns poorly, or a visual defect that technically falls inside an automated tolerance. That is why serious production combines measurement with experience. Quality control can include paper testing, print inspection, dimensional checks, binding checks, cover inspection, and sampling throughout the production line. The final goal is not simply to make a book that exists. It is to make one that survives handling and still feels right. And the numbers behind this industry are enormous. Paper itself is one of the world's major manufactured materials, with global production measured in hundreds of millions of tons. The book supply chain therefore connects forestry, recycling, chemicals, energy, paper manufacturing, printing, logistics, publishing, retail, and increasingly digital production systems. There is no single global number that accurately describes books produced every year because publishers count titles, copies, editions, and formats differently. But the scale becomes clear when you realize that even a single bestseller can require enormous quantities of paper and coordinated production across multiple countries. Did you know the paper industry does not depend entirely on freshly harvested trees? Recovered paper supplies a major share of fiber in many markets, while mills can also use agricultural residues and other non-wood sources for particular applications. Did you know paper mills can recover energy from processed byproducts, helping some integrated operations generate significant amounts of their own heat and electricity? And did you know that the environmental impact of paper varies dramatically depending on the fiber source, energy system, recycling pathway, transportation, and manufacturing technology? Here is another fact that changes the way you see a book. One peer-reviewed life cycle study examined a paperback book produced with paper made in the United States and printing performed in Canada. For that particular production system, the researchers estimated about 2.71 kilograms of carbon dioxide equivalent per book across the studied cradle-to-gate boundary. That number is not a universal carbon footprint for every book, because size, paper, energy, transportation, print run, and manufacturing choices can change the result dramatically. But it reveals something important. The object in your hands carries a much larger industrial journey behind it than its quiet appearance suggests. Over the last 50 years, the transformation has been enormous. Computerized publishing replaced many older pre-press methods. Computer-to-plate systems streamlined plate production. Automated inspection improved consistency. And digital printing created new possibilities for short runs and personalized production. Yet the basic physical challenge remains surprisingly familiar. Create a strong sheet, put the right marks on it, arrange those sheets in the right order, and bind them into a durable object. Technology changed the speed and precision, but the fundamental craft never disappeared. And this is where it gets truly extraordinary. Future book factories are likely to push further into automated inspection, connected machines, predictive maintenance, more efficient materials, lower impact inks and coatings, smarter recycling systems, and increasingly flexible digital printing. Instead of producing millions of identical copies, some facilities can respond to demand with shorter runs, reducing the need to store unwanted inventory. The factory of the future may not look less industrial. It may look even more intelligent, with every sheet tracked, measured, printed, folded, and bound as part of one connected system. Now follow the journey backward for a moment. A tree or recycled sheet becomes fiber. Fiber becomes pulp. Pulp becomes paper. Paper becomes printed pages. Printed pages become signatures. Signatures become a book block. The book block becomes a finished object through cutting, folding, gluing, pressing, inspection, packaging, and transportation. What happens next surprises even experienced engineers. After all those machines are finished, the final test is still incredibly simple. Someone opens a cover, turns the first page, and decides whether the book feels right. So the next time you walk past a bookshelf, stop for a second, look at the cover, the spine, the clean edge of the pages, and the tiny details you normally ignore. Behind that quiet object is an international supply chain, enormous machines, chemistry, heat, water, precision engineering, skilled workers, computer systems, and countless decisions about quality and materials. Most people never see any of it. They only see a book. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.